Hey, good morning, sorry, good evening everyone. As you know, this is Arun, your physics teacher. You know, we have been discussing about electric charges and fields. Electric charges and fields. I'm going to continue that today. Uh, yes. Okay. Before I continue that, yes. Before I continue it, let me give you the details regarding the Unacademy's plan. That is, so best plans for Karnataka we have, that is for 12 months it is 12,375, for 6 months it is 10,125, and for 1 month it is 2,250, and the comprehensive batch is live for the complete syllabus preparation. You can subscribe to this Unacademy by considering my referral code, Arun K live. You can consider that one, fine. And what are the things available in this? Obviously the premium content at the affordable prices. Exam prep PUC. Hi, how are you? Hope you're doing good. Yes. Yes, premium content at the affordable prices. Structured live classes plus dedicated live doubt clearing sessions. Quizzes at the regular interval of time, badges for the complete preparation, test series for DPPs, full length mock tests, etc. with analysis, single subscription for unlimited access, obviously, right? So, as I said, the comprehensive batch is live, right? Yes. So, that has already begun in the month of September, right? That's this month beginning itself, right? So, you will be having the complete syllabus covered, tips and tricks by the top educators, topic wise practice questions, full length mock tests, and you're going to get this at the rate of 2,250 till 30th of September only, right? If you want to avail this offer, you can get it till the end of the September, and you can use the code Arun K live, so that you're going to get a best discount possible, fine. Now so in our previous class we have discussed about the concept of electric charges, right? In today's class, we are going to discuss about electric field, right? So what do you mean by an electric field? The first question comes to everyone's mind, that is, what do you mean by an electric field? So if we define electric field as, or electric field intensity as, the force experienced by unit positive charge. Bhuvan Kumar, hi, hope you're doing good. So I hope you are enjoying the physics classes. If you want to discuss me a specific chapter, you can tell me that one also, so that I can discuss the same chapter whichever you want, fine, from your first PUC as well as from your second PUC. Okay. So we define electric field intensity as the force experienced by a unit positive charge at a point, right? We define electric field as the force experienced by a unit positive charge placed at that particular point. Sir, what do you mean by this, if you ask me? Yes, I would like to explain you that, because it is a simple concept which you are supposed to understand clearly, right? Say you have a positive charge, fine. You have a positive charge Q, and I have placed a small test charge, any infinitesimally small test charge. We call this one as a source charge, and this one as a test charge. Source charge and test charge, fine. Now I have placed a small test charge, right? So if you ask me what do you mean by test charge, an infinitesimally small value of charge which has been kept in an electric field too, so that you can experience electric field, that's it. Or you can experience electric force. It should not apply the electric force on the the force applied by this on any of the other charges would be negligible, right? Now I'm going to consider such a small test charge, placed at a distance of r from a source charge. Placed a distance of r from a source charge. Fine. Now, the force experienced by this test charge at this particular point, the force experienced by this test charge at this particular point is defined as electric field. Let me make it still more simple. Let me understand. Let me clearly make you understand what do you mean by electric field, which will give an immense pleasure for you. Say, it has been kept at a distance of r, right? Then what is the force experienced by this unit positive charge due to the source charge? It is F would be equal to K into Q naught divided by R square, right? Now, if I increase this distance, say it is 10 r, the distance from the source is 10 r, right? Then the force F1 will become K into Q naught divided by 10 r whole square, it is 100 r square, right? So you can clearly see that, yes, the force, the electrostatic force experienced by any of the positive charge, any charge is going to vary with respect to distance, right? It is inversely proportional to the square of the distance, right? Now, so I could see that as the charge has moved to a distance of 10 r, the force experienced by the test charge has got decreased, right? Now, if I increase that to say 50 r, the force will still decrease, right? Are you following it? Now, try to understand this now. So, as I keep varying this distance, there will be a particular point at which the force experienced by this would be equal to 0. That is, the force experienced by the test charge would become equal to what? This 0. Right? That is, as and when you increase the distance, the force experienced by a given test charge is going to decrease with the square of its distance, right? Now I have reached a point where I could see that there is no force exerted by the charge Q on Q naught, right? Hagadre, if I move a point beyond this, this Q naught is going to experience a force due to this Q, right? But if I move a point away from this, the force is not going to experience any sort of force above this point because the distance has got increased, right? Hagadre, this source charge will form a imaginary boundary. The region, a space around a source charge. The space around the source charge. Where the test charge will experience an electrostatic force of attraction or repulsion. Such a region around a source charge will be called as a electric field. I repeat. The region or space around a source charge where the test charge experiences electrostatic force of attraction or repulsion due to a source charge. Such a field or such a space is called as what? Electric field. How do you define it? Yes, I'm going to define it as what? E is equal to F divided by Q. Force per unit charge, right? That is, unit of this electric field is Newton per coulomb or volt per meter. Newton per coulomb or volt per meter, right? Now, this is with respect to potential. The volt per meter which I have written, this is with respect to potential. This is with respect to force. Right? We have both the units for electric field, either Newton per coulomb or volt per meter. Fine. Now, yes, we have written that one. That is Newton per coulomb, volt per meter, or Joule per coulomb meter also can be used. Right? What is the dimensional formula for this? Yes, you write a dimensional formula for force that will become 1 in m, 1 in L, minus 2 in P. What is the dimensional formula for charge? It is nothing but A into T. If you simplify that one, you're going to get the dimensional formula for electric field. That is, if you write that one, 1 in M, 1 in L minus 2 in T divided by 1 in A, 1 in T, right? So this would become the dimensional formula. So if you simplify, right, this would become the dimensional formula for electric field, right? E, electric field dimensional formula will become 1 in M, 1 in L minus 3 in T minus 1 in A is the dimensional formula for electric field, and this electric field is a vector quantity. This electric field is a vector quantity. Fine. So electric field is a vector quantity. Now, sir, if electric field is a vector quantity, then what is the direction of it? Keep the point very clear. At any point, if you want to find what is the electric field, at any point, if you want to find the electric field, at that point, place a test charge first. At that point, place a test charge first. If you place a test charge at that particular point, the direction in which the test charge moves, that is the direction of an electric field. The direction in which a test charge moves, that is the direction of electric field. That is the direction of electric field. I hope it is very, very clear. That is, if you have a source charge as positive charge, if you place a test charge here, in what direction this test charge will move? Positive and positive, what happens? Ripples, it will tend to move in this direction. So for a positive charge, electric field would be acting radially outwards. Right? Same for a negative charge if you find, see, if I replace this by a negative charge, what happens? It will tend to attract this Q0, right? So Q0 will tend to move towards the source charge, right? So that will become the electric field direction for the minus Q. That is, electric field for negative charge would be acting radially inwards. Right? Keep the things in mind. Electric field due to a positive charge would be acting radially outwards. Electric field due to a negative charge would be acting radially inwards. Keep the things in mind. Fine. Now, yes, let us take an entry into the questions. Before I take the entry into the question, I would like to give you what is the equation for electric field due to a point charge. Right? Now, so by the basic definition of this, let us derive the equation for electric field due to a point charge. Yes. So let me consider a source charge Q at a distance of R. I have placed the test charge Q0. E will be defined as F divided by Q0. Am I correct? So what is the value of F here? It is K into Q1 into Q2 divided by R square divided by Q0. Am I correct? What is the value of Q1 and Q2? Q1 is Q and Q2 is Q0. So I can write K into Q into Q0 divided by R square into Q0, right? Q0 and Q0 will get cancelled. So E would be equal to K means 1 divided by 4 pi epsilon naught to Q divided by R square. Q divided by R square. That must be the formula for electric field, right? Now, in a similar way, you can find for system of number of charges, that is K, if you take it as common, then E for n number of charges, that is, we call it as a principle of superposition, right? E would be equal to K into Q1 divided by R1 square plus Q2 divided by R2 square, so on till Qn divided by Rn square. Okay. We call it as a principle of superposition. Principle of superposition. Is that clear, everyone? Yes. Yes. Okay. So let me go on then. Okay. Let us solve the first one now. An electron, obviously the mass of the electron is 9.1 in 10 power minus 31 kg, right, is sent into the electric field of intensity 9.1 in 10 power 6 Newton per coulomb, right. An electron has been sent into the electric field of 9.1 into 10 power 6 Newton per coulomb, right. Now, the acceleration produced is, you're supposed to find what is the value of acceleration. Let us find that one, right. Now, see, let me consider an electric field here. How do a acceleration is going to get produced in an electron? Let us see. Just now I have been discussing electric field for a positive charge would be radially outwards, electric field for a negative charge would be radially inwards, right. So I can say the beginning point of this must be positive and this point must be negative, right. Now, say if you have projected an electron in the electric field of 9.1 into 10 power 6 Newton per coulomb, right. Now, what happens to this electron? See, negative and negative will get repelled in this direction, negative and positive will get attracted in this direction. So, the electron is experiencing the force in this direction. Someone is pulling the electron. Am I correct? If someone is pulling the electron, what happens? Right? Obviously, the electron will start to move. Right? If the electron starts to move, obviously the electron will gain the velocity. If the electron is going to gain the velocity, then it is going to accelerate. Right? Then, are you following it? Now, if the electron gains the velocity, then it is going to accelerate. I am supposed to find what is the acceleration produced by that electron, right? Now, how to find that one? Obviously, how will you find acceleration? F is equal to m into u, right? I am supposed to find a. A is equal to what? F divided by m, right? The force is getting acted on the electron due to the electric field. So, how do you define electric field with respect to electric force? E is equal to F divided by Q naught, or F is equal to what? E into Q naught. Right? So replace F by E into Q naught here, divided by M. A is equal to E into Q naught divided by M, right? E value is how much? 9.1 in 10 power 6 multiplied by, what is the charge of an electron? It is 1.6 in 10 power minus 19 divided by, what is the mass of an electron? It is 9.1 in 10 power minus 31, right? So 9.1 will get cancelled. So acceleration of the electron gained due to the electric field is given by A is equal to 1.6 in 10 power minus 19 in 10 power 6 into 10 power plus 31, right? 31 plus 6 is 37, 37 minus 19, right? A would be equal to 37 minus 19 is, how much is that? 37 minus 19, so it is 27 means 10, obviously. Sorry, 29 means 10, right? 29 plus 8, so 10 plus 8 is 18, right? So it is 1.6 in 10 power 18 meter per second square, right? So 1.6 in 10 power 18 meter per second square. That's option A must be the answer, right? A simple question to begin with, a very very simple question, a basic level question, right? Next. Two charges, 50 microcoulombs and 100 microcoulombs. Two charges, 50 microcoulombs and 100 microcoulombs are separated by a distance of 0.6 meters. Right? Two charges of 50 microcoulombs and 100 microcoulombs are separated by a distance of 0.6 meters. Right? The intensity of the electric field at a point, the intensity of the electric field at a point midway between them. So what is this midway? Exactly at the center. Exactly at the center, right? If you find what is the electric field exactly at the center due to the two charges, that would be the electric field at that particular point, right? So let us try to understand the question now. Okay, now, so let me consider two charges, 50 microcoulombs and 100 microcoulombs. They have been separated a distance of 0.6 meters apart. Let me cross verify the data which I have written, whether it's correct or not. Fine. Now, yes, 50 microcoulombs and 100 microcoulombs, and the distance is 0.6 meters, right? Now, I am supposed to find what is the value of electric field exactly at the midway, right? Remember what I said just now in the beginning. Whenever you want to find what is the whenever you want to find what is the electric field at this point, at any point, what I asked you to do, I just asked you to place the test charge at this particular point. That is, I have placed the charge Q, a positive charge always, right? Now, what is the direction of electric field due to this 50 microcoulombs on this Q bond? Both are positive, right? So, say let me call it as A and this as B. What is the direction of electric field? Electric field is acting in this direction. EA is acting towards 100, right? Let me write the value of EA. EA is given by, what is the expression we know for a point charge? It is K into Q divided by R square, right? QA RA divided by R square. K value is how much? It is 9 into 10 power 9, right? Multiply by 50 into 10 power minus 6, because it is given microcoulombs, divided by, what is the distance between these two? Yes, total distance is 0.6. At the midway, so it is 0.3, right? 0.3 or 10 power minus 1 whole square, it becomes 9 into 10 power minus 2, right? 9 and 9 will get cancelled. So EA, this is the magnitude of EA which I am writing. EA would be equal to 50 into 10 power 9, 10 power minus 6, it is 10 power 3, 10 power 3 plus 10 power 2, it is 10 power 5 Newton per coulomb. Right? 50 10 power 5 Newton per coulomb. Now, what is the direction of electric field due to this another positive charge? This is acting in this direction, because positive and positive will get repelled. It is have to move in the direction away to you. So it is EB, right? So EB would be equal to K into QB divided by RB square, right? Now, K value is 9 into 10 power 9 multiplied by 100 into 10 power minus 6 divided by RB. What is the value of distance between B and this point Q naught? It is also 0.3, right? Now, so if both are acting, now 0.3 means it is nothing but 9 into 10 power minus 2, right? So 9 and 9 will again will get cancelled. So EB will be equal to 100 into 10 power 5 Newton per coulomb. Always remember this one. Always remember this. What is that? Right? Always remember this. If you have two like charges, the electric field due to both the charges at any point in line joining along the line joining between the two charges. Remember, if you have two like charges, and if you want to find electric field along any point in midpoint, any point here, right? At any point, right? The electric field due to both would be always acting in opposite direction. If you have unlike charges, one the positive, another negative, right? When you have positive and negative, then electric field at any point along the line joining between the two charges would be acting in the same direction. In this example, I have like charges, so both are acting in the opposite direction. If they are acting in the opposite direction, remember always, what is that? Yes, subtract. E net would be equal to always E greater minus E lesser. Remember, if any vector space, it need not to be an electric field, need not to be electric force, it can be any electric, it can be any vectors, always. Because the angle would be 180 degree. If the angle is 180 degree, it becomes A, P minus Q whole square. So resultant would be P minus Q always, right? And the resultant always acts in the direction of the greater magnitude. Remember it, right? So that's why the vector is very important for your PUC. There is your first PUC and your second PUC, both. Okay. Now E net would be equal to what? E net would be equal to, it is E greater. Which one is greater? It is EB minus EA, right? By looking at that only you can say EB minus EA. What is EB? It is 100. This is 50. So it must be 50 into 10 power 5. Must be the value of E. Hagadre, next time if we are going to get this kind of problem, directly ಏನು ಮಾಡಬೇಕು ನಾವು E net ಇಂದ consider ಮಾಡಿ. E net is equal to what? EB minus EA. Fine. So you can take out K common. So it is Q by R square, QB divided by RB square minus QA divided by RA square. Right? Directly substitute, simplify. You are going to get the same answer again. Nothing to worry. Fine. Now, hagadre, do we have the answer this one? How much we have got? It is 15 10 power 5 Newton per coulomb. Yes. 15 10 power 5. Do we have? Or 5 into 10 power 6. Right. So answer option B must be your answer. Correct? Next. Two charges 4E and E are at a distance x apart. Two charges 4E and E are at a distance of x apart. Right? At what distance a charge Q must be placed from a charge E so that it has to be in equilibrium? Remember, what is the shortcut I have given you for equilibrium in the previous class? I have given you the shortcut. What is that? Remember, x is equal to what? D divided by, x is equal to D divided by square root of Q2 by Q1 plus or minus 1. I hope you remember this shortcut. If you don't remember this, if you don't remember the shortcuts, then it will be difficult for you. Please, 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 you remember the shortcuts. Fine. So remember the shortcuts so that your problems will get solved like this. Fine. So x is equal to what? So D divided by square root of Q2 divided by Q1 plus or minus 1. Plus for like charges and minus for unlike charges. Right? Now, do I have a plus charge or a minus charge? I have both the charges are plus. Both are separated by distance of x. Now, let us see how quickly the problem will get solved. Distance is what? X. I am supposed to find x. Let me consider it as D. Fine. Reverse it. That's it. X divided by square root of what is the value of two charges? It is Q2 is 4E and Q of E is E, right? Q1 is E, right? So I can write this one as what? 4E divided by E plus 1, because I am taking plus 1. Why? Because both are like charges. E and E will get cancelled. So D would be equal to x divided by root of 4 is 2 plus 1. So D must be equal to x divided by 2. Option C. See how easily we are getting it. In the previous class, I have given you the shortcut. Go to the previous class and check it out. Fine. I think it was on 21. I feel it was on 25. Yes. It was on 21. Yes. The class has been taken on 21 on the electric force. Right. Go to that class. Check it out. What is shortcut I have? How exactly I have derived the shortcut, so that you can easily remember that one. Fine. Next. Okay. The intensity of electric field required to balance a proton of mass. The intensity of electric field required to balance a proton of mass 1.7 in 10 power minus 27 kg and charge 1.6 in 10 power minus 19 coulombs is nearly equal to what? Right? Is nearly equal to what? Right? See, this is a small, very small tricky question. Right? Try to understand what is the meaning of this question. Right? See, a proton is there. Right? A proton is there. If you consider a proton like this, right? If you leave a proton like this, what happens? The proton will fall onto the Earth's surface. Any object with the mass m, it is going to fall onto the Earth's surface. Right? Right? Correct? Now, what you are supposed to do is, you are supposed to balance that one. You are supposed to balance it. How do you balance it? You are supposed to apply the electric field. Let me show you with the diagram. Right? Say, I have a proton. Right? I have to balance this. How to balance this one? Due to mg acting downwards, it is going to fall onto the surface. Right? Now in Martini, I will apply an electric field. Such that here is positive and here is negative. Right? So the electric field is going like this. Fine. Now what exactly is going to happen? The positive and positive will get repelled, positive and negative will get attracted. So this is going to experience a vertically upward force, Fe, that is electrostatic force of attraction as well as repulsion. Right? Now this has to get balanced with mg. Andre Fe must be equal to mg. Fe must be equal to what? Mg. This is the concept which you are supposed to apply to this. Fe must be equal to what? Mg. Now we find ಮಾಡಬೇಕು. You are supposed to find what is the intensity of electric field you are supposed to apply. Intensity of electric field na find ಮಾಡಬೇಕು, right? Now, how do you relate this electric force and electric field intensity? E is given by F divided by Q naught, or F is equal to E into Q naught. Right? Now, so what this will happen? Instead of Fe, I can write E into Q naught. That is equal to what? M into G. E value na find ಮಾಡಬೇಕು. So E is equal to M into G divided by Q naught. Right? Now, what is the mass of the proton? It is 1.6 in 10 power minus 27. Right? Multiplied by G is 10 divided by what is Q naught? Q naught is 1.6 into 10 power minus 19. Charge of a proton. Triveni Shetty, sir, is KCET syllabus reduced? See, the thing is, now NCERT, they have reduced the syllabus for this year. That is, for second PUC, they have reduced the syllabus from NCERT. Right? Now, again, the state board lecturers will sit for a meeting, and they will decide whether the syllabus has to be reduced or not. And it is yet to come. Fine? If it gets reduced, if the syllabus gets reduced, means obviously for CET also, whatever the reduced syllabus is there, the same syllabus, the questions should be asked on the same syllabus. Nothing to worry about it. And one more thing I'll tell you. If NCERT has reduced the syllabus, means Karnataka State Board also is going to reduce syllabus. That is the assurity from my side. Fine? Okay. Now, so 1.6 and 1.6 will get cancelled. Now E would be equal to 10 power minus 27, 10 power plus 90. That would be equal to 10 power minus 27, 10 power plus 19. How much that? It is 1 plus 7, it is 8. That is 10 power minus 8 into 10. So into 10, right? That must be your answer. So you are supposed to apply the electric field of 10 in 10 power minus 8 Newton per coulomb. Right? So, do you have the answer? Okay, I have 1 in 10 power minus 7. Both are similar, I feel, because E is equal to what? 1 into 10 power minus 7 Newton per coulomb. I got 10 in 10 power minus 10. Fine? 10 in 10 power minus 8 I got. So, if I reduce that, it is 1 in 10 power minus 7. Yes, thank you. Sir, where are you from? I am from Shumaga, Triveni. Where are you from? Okay. An is placed along the x-axis. Try to understand the question. An electric dipole is placed along the x-axis at an origin of. I'm from Ballari. Okay, very good. Hope you're enjoying the class 3. Thank you. An electric dipole is placed along the x-axis at origin. Right? A point P is at a distance of 20 centimeters. A point P is at a distance of 20 centimeters from the origin, such that OP makes an angle of pi by 3 with x-axis. OP will make an angle of pi by 3 with x-axis. Right? Try to understand the question. If electric field makes an angle theta with x-axis, the value of theta is, you're supposed to find the value of theta. Try to understand. Sir, actually I am in class 11. Okay, you would have enjoyed. So you can see motion in a straight line and few more topics which I have discussed for class 11. Right? You can enjoy that one also. Right? You can watch the class and you can join the Unacademy for any sort of doubt clarifications. Or you can ask me in the YouTube class also. Nothing fun. Right? Now, so I have an electric dipole placed along the x-axis at the origin. Right? So let me consider this question. Right? We know a concept of electric dipole of positive. What do you mean by a dipole? First, what do you mean by a dipole? A dipole is a system of equal and opposite charges. Which is separated by a small distance of p. Right? A dipole is a system of equal and opposite charges which is separated by a small distance. So, what is that one? If this is plus q, this has to be minus q. Right? So, it's a system of equal and opposite charges which has been separated by a small distance. Right? Now, we know what is the electric field along the axial line. Equation to find what is the electric field along the axial line, and equation for electric field along the equatorial line. Right? Now, but in this one we have a small trick. From today I will see videos. Sure. Thank you so much, Triveni. Thank you. You can start watching the videos of all the subjects, whatever it is available, and you can see and you can get the free classes of Unacademy in the Unacademy app also. We have the free class also. We call it as special classes. There also you can watch number of videos. You can download that Unacademy app and you can enjoy your class 11th syllabus. Please. Okay. Now, so it is plus. So I have a dipole. Now I'm in a situation where we can see the electric dipole is placed along the x-axis at the origin. At a point P at a distance of 20 centimeters from the origin, OP makes an angle of pi by 3. Andre, the given point where you want to find the electric field is neither along the axial line, it is nor along the equatorial line. Right? Equatorial line is a line which divides the dipole into two equal halves. Right? So you have a point now. Which is neither along the axial line nor along the equatorial line. Right? For this, it is a special case. That is, we call it as a general case of the case. Say, you're supposed to find the electric field due to this dipole along this point P. Right? Even the special case now, we are going to learn in the competitive syllabus only. Meaning, theory syllabus you are supposed to learn in this competitive syllabus only. Right? Now, how to find the electric field due to this dipole? Now let us see. Right? Just I take hardly 1 or 2 minutes of time so that I'll derive that equation, because you cannot remember everything. Right? Now, so this is at a distance of r from the center. Fine. This would be L. and this is not your r square plus l square also, because it is not your Python, it is not your right angle triangle, so that you can say this r plus l, right? Now, how to find the dipole? How to find the electric field due to this? Let us say, let me call it as the distance is, say this is r1, and the distance from this negative is r2. Fine. Now, hagadre electric field due to this positive charge would be acting in this particular direction, and due to this would be acting in the downward direction, obviously, right? Now, hagadre E1 or E plus would be equal to K into Q divided by R1 square. K into Q divided by R1 square. Adhe riti, E due to negative is what? It is K into Q divided by R2 square, because I have considered the distance from the negative charge to point P is R2. Adhe riti, distance of the positive charge to point P is R1. Right? Now, if you find the E net would be equal to square root of E1 square, E plus square plus E minus square, of E plus square plus E minus square plus 2E plus into E minus cos theta. Right? Okay, that is there. To get that, I am supposed to know what is the value of R1 as well as R2. Right? So, to get the value of R1 and R2, what I will do is, if this is L, let me just extend this one. Fine. So, which becomes a right angle triangle. Now, this is positive, this is negative. I will point somewhere here. I will done this. This is R, right? So we consider this one as R1, and obviously the distance between the two charges is 2L, right? So this is nothing but L, this is also L, right? Now I can clearly write, see, this is nothing but L. If I just extend this, say let me call it as O, this is A, this is B, this is C, this is P, right? Now, so the special class link in the description is not working. It must be working, no? You must download the app, without which it won't work. Fine. Now this is your L, right? Now if the triangle is small, if the right angle triangle is small, then the hypotenuse will be equal to the opposite side. This is the concept. What is that? If the triangle is small, the hypotenuse would be equal to opposite always, right? Then I can write BP is almost equal to what? AP. BP is almost equal to what? AP. Right? Now, how to get the value of this? Because I want to find what is the value of BP square, which is nothing but R1 square. Right? How to get the value of that? Let us see now. See, this L is acting at an angle theta. Right? So this must be your L cos theta, and in this direction it must be L sin theta. Right? Hagadra, if this would become your L cos theta, this is your R means, then the total distance AP would be equal to R plus L cos theta. AP is R plus L cos theta, means BP, that is nothing but your R1, that is also what? R plus L cos theta. Did you understand? Now, in a similar way, you can consider this one, right? So I will just draw the line. So it is, let me call it as C, right? Now again I can find one more right angle triangle. In this one more right angle triangle, right? So I can say again hypotenuse is equal to opposite. If what is that? If the triangle is small, then from this one is PC would be equal to PC would be equal to, sorry, just let me call it as D better. D. PD would be equal to PC, right? PC is R2 we have considered, right? So this R2 would be equal to, see, this whole is, if this is L, this would be again L cos theta itself, right? Now if this is L cos theta, now the total distance is R, I want only this distance, it would be what? R minus L cos theta, R minus L cos theta. So R2 would be equal to R minus L cos theta, right? So BP would be equal to R1 is equal to R plus L cos theta, and R2 is equal to what? R minus L cos theta, right? Now, so let us substitute that one. What is that? E due to positive would be equal to K into K2. Q divided by R plus L cos theta whole square. Adherity, E due to negative would be equal to, it is K into Q divided by R minus L cos theta whole square. R minus L cos theta whole square. Right? Now. See. You are supposed to find what is the value of E net at P. Right? You are supposed to find what is the value of E net at P. Right? How will you find the E net at P is the biggest question. Right? How will you find the value of E net at P? See, this concept is not in any of your textbooks. Right? You can find in, you can search in any of the textbooks. You are not going to find this one. Right? This is clearly built one, and we have to refer so many textbooks so that I can get this equation, right? So how do you calculate? The concept of the electric field at this point. Let us see. At this point P, let's say this is your point P. Due to E positive would be acting in this particular direction. Due to E negative would be acting in this particular direction. Correct. It is very clear that this positive and this negative, right? So the angle in both would be equal to 190 degrees. Right? Hagadra, resultant of this would be acting somewhere in this direction. We make an angle alpha with E positive. Right? We make an angle alpha with E positive, and this is E negative. Right? Now, if that is the case, the angle between E plus and E minus is 90 degrees, then E net would be equal to what? Square root of E1 square plus E2 square. Right? It is nothing but square root of E1 square plus E2 square. Now, yes. Now, I can take out K square Q square common, right? I can take out K square Q square common, right? If I can take out K square Q square common, right? Now, if I can take out K square and Q square common, right? Now what happens? Let us see. Yes. Okay. K square Q square, if I take out common, if it is outside the root, so K into Q is outside the root. Square root of 1 divided by R square, R plus L cos theta whole square plus 1 divided by R minus L cos theta whole square. R minus L cos theta whole square. If you simplify this, taking the this whole as a, if you simplify this, let me this one. If you simplify this, so what happens? E would be equal to K into Q into square root of, see, R square, I just expand this, R square plus L square cos square theta, right? Next, minus 2 RL cos theta, right? Adhe riti, we are going to multiply this here. So plus R square plus L square plus 2 RL cos theta, right? Which has been divided by, you know, R square plus L square cos square theta. See, this is A plus B into A minus B. How will you write this one? A plus B into A minus B, A square minus B square, right? A square minus B square is what? What is that one? It is A square is R square minus L square cos square theta whole square, right? R square minus L square cos square theta whole square, right? Now, yes, if you simplify all those things, this E would become equal to, what is that? See, K into Q, cos square theta is minus, of course, minus 2RL plus 2RL will get cancelled. R square plus R square is R2R square plus, you know, 2L square cos square theta is there, obviously, right? So L square cos square theta plus L square cos square theta, obviously it becomes 2L square cos square theta, right? Now I can simplify this, and I can write square root of, yes. So this can be written as, R square, so 2R square plus 2L square cos square theta divided by, you know, R square minus L square cos square theta whole square. If R is very much greater than L, you can neglect this, right? If you neglect that one, E would be equal to, the whole equation is going to get simplified to, see, you can take out L square common, you can simplify that one, you can take out R square common, you can simplify that one, the whole equation would get simplified to P divided, because L would come outside, right? If L would come outside, means, so you can write it as P, because Q into 2L is nothing but P, right? P divided by 4 pi epsilon naught R cube into square root of, how much is this? The square root of, how much is this? It is, yes, 3 cos square theta plus 1. This is the equation to find the electric field. Right? Now, equation to find tan alpha, right? You are supposed to use this one, right? Equation to find tan alpha, that is direction of the resultant. Tan alpha would be equal to E2 divided by E1, right? If you substitute and simplify, it would be half tan theta, right? So tan alpha is equal to half tan theta. E is equal to what? P divided by 4 pi epsilon R cube into square root of cos square theta plus 1. This is the equation I am going to use now. Now, find ಮಾಡಬೇಕು. So it is positive and negative. So placed by making an angle of pi by 3, another 60 degrees. You're supposed to find what is the direction of electric field. Electric field if the electric field makes an angle theta with the x-axis, the resultant angle is not alpha now. This would be theta here, right? I am supposed to find the value of theta. This one you are supposed to consider it as what? Alpha. This is alpha, you are supposed to consider it as theta. The angle between them is you are supposed to consider as pi by 3, right? Then tan theta would be equal to half into tan tan pi by 3 raised to tan 60. Tan 60 is how much? It is root 3, right? So tan theta is equal to root 3 divided by 2, right? Tan theta is equal to root 3 divided by 2, right? Now, here you have one more thing to understand, right? Because if this is theta, see, this one would become alpha. I am supposed to find the value of theta, right? I have found the value of alpha. Sorry, this is alpha, right? So theta would be equal to alpha plus pi by 3. Am I correct? Because exterior angle is equal to sum of opposite interior angles. So theta would be equal to alpha plus pi by 3, right? Alpha plus pi by 3, right? So what is alpha? Alpha is nothing but what? Tan, see, tan alpha I have got as root 3 by 2, or alpha is equal to what? Tan inverse of alpha is equal to what? Tan inverse of root 3 by 2, right? So theta must be equal to pi by 3 plus tan inverse of root 3 by 2 must be your answer, right? So the answer must be option B. The answer must be option B, right? So these are the typical questions which you will come across in any of the competitive exams, right? So I'm going to continue this. In the next class also. Please keep watching my YouTube channel, the Unacademy, and have a great day. Bye bye.